So, in this lesson, we are going to be doing a short review of the topics that we discussed with concentration. Just going to change my ink color really quickly. So, when we talk about concentration, we are expressing it in a unit called molarity. Molarity is given by a capital M. Please don't use lowercase m because that's for meters or mass. Molarity is going to equal the number of moles of solute that are dissolved in liters of solution. What that equation looks like, molarity equals moles of solute on top and liters of solution on the bottom. When we're solving molarity problems, step one is we determine what the variables are in the equation. We plug them in, and then we solve for the unknown in that equation. To help you out with that, we will be using the concentration pyramid or triangle. We know that when we are solving for molarity, we have moles on top and we have liters on the bottom. If you're solving for liters, we cancel out the L, we have moles on top, and we have molarity on the bottom. And finally, if we are solving for the number of moles, then we have capital M for molarity on the bottom times liters. So these are the three possible equations that you will use when solving for any of the variables in a concentration problem. We're going to look at two examples together. In our first one, they are asking us what is the molarity of a 4.5 liter sodium hydroxide solution that is composed of 2 moles. We already have the equation set up. Molarity is going to be moles of solute divided by liters of solution. Our problem tells us that we have 2 moles and we have 4.5 liters. We type that into our calculator. 2 divided by 4.5 gives us 0.44. And since we're solving for molarity, our unit is going to be M. And we know that M is a ratio of moles over liters, which makes sense based on the setup of our equation. In our second example, they tell us that we have a 2 molar sodium hydroxide solution that has 4.5 moles, and it's asking us how many liters of the NaOH solution do we have. So for this one, since we are solving for liters, we are going to have moles on top, and we are going to have molarity on the bottom. The problem tells us we have 4.5 moles and 2.0 molar. 4.5 divided by 2.0 gives us 2.25. Since we're solving for L for liters, our unit is going to be L as well. If you want to double check your units, if we look at our equation right here, we have moles on top and we have molarity on the bottom. And we know that molarity is moles divided by liters, so we can plug moles divided by liters in. Moles cancel out, we have liters remaining. There are going to be 4 problems that are coming ahead that are just extra practice. These questions are not written out in your handout, but I would highly suggest that you attempt them. It will be very good preparation for your test coming up next week. So when the question comes up, pause the video, solve the problem, and then resume the video to check your solution. Next topic that we discussed were dilutions. We use the example of lemonade with this. If you make lemonade on a hot summer day and it's just too lemony or too sweet, you can dilute it in order to lower the concentration of that bitter lemon or the sweet sugar. When we do dilutions, we need to be able to calculate the new concentration or the new molarity of our solution. To do that, we use the equation M1V1 equals M2V2. You can also sometimes see this written as MIVI equals MFVF. Now, what do these variables stand for? Number 1 indicates initial, and the number 2 indicates final. So M1 is our initial molarity, M2 is our final molarity. V1 is our initial volume, and V2 is the final volume. The biggest mistake people make when setting these problems up is mixing up what is the initial and what is the final value for each of your variables. We can identify concentrations and volumes solely by looking at the units in the problem. If a value has a unit of capital M, or if it says the concentration, or if it says the molarity, we know that unit is going to be M and it's going to be concentration. Unlike for molarity, for volume, we don't necessarily have to use liters. If you see liters, you know it's volume, but we can also use milliliters for this. As long as V1 and V2 have the same unit, it doesn't matter if it is L or ml. For example, if I dilute 250 milliliters of 0.1 molar lithium acetate solution to a volume of 750 milliliters, what will the concentration of this solution be? So it's saying that you're diluting a solution that you already have. If you already have this solution in order to dilute it, that means it's going to be your initial or one value because it's what you already have in the beginning before you do any type of changes. So 250 milliliters is going to be V1. We know that milliliters is our unit for volume. So for V1, we will put 250 ml and 0.10 for molarity. Anytime we see an M, we know it has to be an M variable. After the dilution, at the end of the experiment, we have a volume of 750 milliliters. So that is going to be V2. And it's asking what is the new concentration going to be. So we're solving for M2. We know that our equation is M1 V1 equals M2 V2. We are solving for M2. So the first thing I'm going to do is rewrite our equation to get rid of V2 so that M2 is by itself. So M2 is going to equal M1 times V1 over V2. We can plug our variables in. We know that M1 is 0.10 molar, V1 is 250 milliliters, and V2 is 750 milliliters. Our mLs cancel out on the top and bottom. We plug it into our calculator. 0.1 times 250 divided by 750 gives us 0.033 molar. In our second example, it says if I have 340 milliliters of a 0.5 molar sodium bromide solution, what will the concentration be if our final volume is 800 milliliters? So again, it says I have. So that means we're starting with these values. So they are going to be our one values. We know that milliliters is going to be volume and M is going to be concentration for molarity. So M1 is going to be 0.5 molar. V1 is going to be 340 milliliters. Our final volume is given as 800 milliliters. So V2 is going to be 800 milliliters. And again, we are solving for M2. I'm going to start with our equation, M1 V1 equals M2 V2. We're solving for M2, so we're going to get rid of V2 to isolate our variable. M2 is going to equal M1 times V1 divided by V2. We plug our values in. M1 is 0.5 molar. V1 is 340 milliliters, and V2 is 800 milliliters. Our milliliters cancel out on the top and bottom. We plug it into our calculator, 0.5 times 340, and divide that by 800 to get a final concentration of 0.21 molar. Again, the next few questions are not in your handout. They are just extra practice, but I would highly recommend in preparation for your test, once the question comes up, pause the video, take the time to solve the problem given, and then resume the video to check your solution.